class, we did graphing linear equations. It was lesson 3.1. The skills we learned were determine whether each function is linear, find x and y intercepts, graph each linear equation using those x and y intercepts. Please use your notes and math book for the key concepts. You can always pause this video and replay. Now let's see one more example from each skill. Determine whether each equation is linear, and here's one example. 36y equals x squared plus 15. Is this linear? What we learned in class was that a linear equation has the form y equals something x plus some number. So does this fit into that? Well, first thing I see is that y is alone. So if I divide each side by 36, I notice 36's cancel out. You're left with y equals x squared over 36 plus 15 over 36. Now this awkward fraction is okay because it is a number alone and it could fit into there. And x squared over 36, that's okay because that's just really 1 over 36 times x squared. So 1 over 36 is a fine slope. But what about x squared? That square right there means that x there should have a square on it, but really it has a 1 on it. Because that has a square and that has a 1, already I know not linear. Example number 2. Find the x and the y intercepts. And we have two examples here. One we have a table and the other we have a graph. In the table, what we learned is the x and y intercepts are where one or the other element is 0. In this case, if I were to do a quick graph, I would go over 0, down 2. So that is showing me where the y-intercept is. And this set of coordinate points over 1 up 0. So over 1 up 0, that's showing me where the x-intercept is because that's the x-axis. So in this case, the x-intercept is 1 and the y-intercept is -2 for this table. So the key here, look for the zeros. Look for the zeros. In this example, to find the x and the y-intercept, I'm looking at the y-axis right there. That's where the line crosses the y-axis, and that's -2. I'm looking for the x-axis, so I follow that around. Oh, right there. And that's positive. Let's put that back in pencil mode. That's +2. So the x-intercept, if I wanted to write it nicely, x-intercept equals 2, and the y-intercept equals -2. The third example that you learned today, graph linear equations using the x and y intercepts. The trick here, again, was the zeros like you saw before. Whatever that 0 is, if we go back to that one, when the x is 0, you get your y-intercept. When the y is 0, you get your x-intercept. So if we make x 0, we know that will be our y-intercept. So x-intercept, you make y 0 and plug in 0 for y. In order to get x alone, do a little bit of algebra here. Subtract 8 from both sides. Negative 8 equals negative 6x. Divide each side by negative 6 to get the x alone. And if I do everything right, if I know that a negative divided by a negative is a positive, and I reduce the fraction 8 over 6, I get the fraction 4 over 3 equals x. So the y-intercept is 4/3. So again, we found it using zeros. Alright, and if we graph it, need some tick marks here. I made a point on the y-axis at 8, a point on the x-axis